the first example on falling film reactor. Okay, an aqueous solution at 25 degrees C flows through a 2 cm radius falling film reactor at an average velocity of 12 cm per second, which forms a liquid film of 2 mm thick on the wall. Okay, so how you are going to imagine how the reactor looks like. So falling film, so you can draw the reactor, okay, as this one, right? So saya ingat tak apalah. So the falling film, so this is the film. Okay, then given the 2 cm radius of the reactor, so 2 cm radius of the reactor, actually from the center, okay, to the wall, this is the 2 cm radius, and we can label it as R0, which is equal to 2 cm. Okay, and then form a liquid film of 2 mm thick. Liquid film yang 2 mm thick. So the thickness of this film is 2 mm. So similar. Okay, both sides similar. 2 mm. Okay, 2 mm. Or in centimeter, because all the unit is in centimeter, 0.2 cm. Okay, then you have the R0. Okay, R0. Where is Ri? Inner. The outer radius is R0, 2 centimeter. So the position of Ri, okay, Ri from the center to the external of falling film. So this point is Ri. Okay, then air at 1 atmosphere pressure 25 degrees C flows in the counter current direction. So sebab liquid film tadi from the top, so that's why it will produce a film on the wall of reactor. Then the gas from the bottom, gas, so from the top is liquid. Okay, gas from the bottom. That's why counter current direction. At average velocity of 2.5 cm per second. So tadi liquid velocity 12 cm per second. So you can jot down the velocity. Okay, velocity U of liquid phase 12 cm per second, and velocity of gas is 2.5 cm per second. Okay. The liquid contains an organic contaminant A with molecular weight of 120, so unit of molecular weight gram per mole, and the concentration, initial concentration of A is 15 ppm. So Ca0 equal to 15 ppm. Then you need to change the unit to mole per volume, which will be removed by the reaction with oxygen from the air. The reaction in the liquid phase is shown as A plus 2 oxygen, and the reaction occur to produce the product, and the rate reaction is R equal to KCaCO2. Okay, where the reaction occur. So yang tu kita akan tengok dalam soalan. Either it is reaction limited or mass transfer limited. And then reaction occur in gas phase or in liquid phase. So in question B will explain about the properties of reaction, because it's not given in the situation of the reaction, but given the reaction in liquid phase. So meaning that rate reaction given here is rate reaction in liquid phase. Okay, so this is the Allah, tak clear. Alright, tak boleh nampak. So rate reaction, why? Okay, salah color. Right. So this is the rate reaction for liquid phase. Okay, next. First question. Calculate the composition oxygen in the liquid phase and gas phases, assuming all the contaminants are consumed in the reaction. So when we talk about the composition, meaning that you need to calculate the number of moles. Okay, basic dia adalah number of moles, not only the concentration but the number of moles, because the reaction occur based on the number of moles. We need to determine which reactant is limiting reactant, which one is in excess. So either A or oxygen in excess. Okay, so determine which reactant is in excess. So we need to determine which reactant in excess, because the question asks you to calculate the composition of oxygen when all the contaminants consumed, meaning that the remaining oxygen. So we need to know what is the number of moles for the reactant A, and also the number of moles of oxygen. So for question A, calculate the number of moles. But based on the data given, what we can actually calculate is molar flow rate. Okay, molar flow rate is referring to the number of moles for the reactants, for both reactants. Okay, so how to calculate the molar flow rate? From the definition of molar flow rate, Fi equal to the concentration multiplied with volumetric flow rate. So we can calculate the concentration, and we also can calculate the volumetric flow rate based on the data given. Okay, based on molar flow rate formula, first we need to calculate the concentration of A and oxygen. So Ca not in liquid phase, because the contaminant A is in liquid phase. 15 ppm. So we need to change the unit, multiply with the density of solution, divide with molecular weight of solution. So given in the question, the molecular weight of organic contaminant is 120. So then 15 ppm equal to 15 10 negative 6 multiply with, assume the density, the contaminant A in water, sebab dia tak mention in the question what type of solution, so we can assume it is in water. So multiply with density of water, which is 1 gram per centimeter cube, divide with 120 gram per mole. So this one given in the question. Okay, 120 molecular weight. Right. Then you will get the concentration of A, initial concentration of A mole per centimeter cube. Okay, next, calculate the concentration of oxygen. Initial concentration of oxygen, but oxygen in gas phase. Okay, this one before reactions, but at initial. Right, equal to partial pressure of oxygen per RT equal to, so oxygen in air, the composition of oxygen in air 21%, so 0.21 multiply with 1 atmosphere. So you will get the partial pressure of oxygen in air divide with, okay, gas constant yang unitnya atmosphere 82 centimeter cube atmosphere per mole Kelvin multiply with, so the temperature at 25 degrees C, so 298 Kelvin. Right, then you will get the initial concentration of oxygen 8.59 mole per centimeter cube. So you have the initial concentration of oxygen and initial concentration of A. Okay. Next step, okay, based on the molar flow rate formula. So we have the concentration, then we need to calculate the volumetric flow rate. Calculate volumetric flow rate. V. Okay, VL and also volumetric flow rate of gas, because given in the question only the velocity. So volumetric flow rate of liquid equal to surface area of liquid multiply with velocity of liquid. Okay, what is the surface area of reaction for liquid? So the formula is pi R naught square minus Ri square. So this formula comes from the cross-sectional area based on the falling film reactor. Multiply with velocity of liquid. So the problem here is we only have R naught and the thickness. So how to calculate Ri? So should be no problem because R naught equal to 2 cm. Ri equal to 2 cm minus thickness of film, falling film, 0.2 cm. So it's Ri equal to 1.8 cm. So this formula comes from the cross-sectional area formula for falling film. Therefore, we can calculate the area of liquid equal to pi 2 cm square minus 1.8 cm square. Right? Therefore, to calculate the volumetric flow rate is equal to pi 2 cm square minus 1.8 cm square multiply with velocity of liquid, which is 12 centimeter per second. Then you will get the volumetric flow rate of liquid. So this is the volumetric flow rate value. Okay, next, calculate the volumetric flow rate of gas. Volumetric flow rate of gas equal to area of gas, surface area of gas, multiply with velocity of gas. Okay. Ag equal to pi Ri square. Ri, we already know the value of Ri, which is 1.8 centimeter. So pi 1.8 cm square. Therefore, the volumetric flow rate of gas equal to pi 1.8 cm square multiply with velocity of gas 2.5 centimeter per second, you will get 25.45 centimeter cube per second. Okay, then after that, next step, third step, calculate the molar flow rate because we already have the concentration and volumetric flow rate. Calculate the molar flow rate. Betul lah. Molar flow rate at initial. So FA0 in liquid phase, because A in liquid phase equal to CA0 of liquid multiply volumetric flow rate of liquid. So just insert all the value. So check the unit supaya unit dia boleh cancel out ataupun standardize. So all the unit is more unit of concentration mole per centimeter cube, unit of volumetric flow rate centimeter cube per second. So we can cancel out the centimeter cube unit, then you will get 3.583 10⁻⁶ mole per second. Similar for oxygen. Oxygen in gas phase, okay, at initial equal to CO2 at initial in gas phase multiply with volumetric flow rate of gas. So 8.594 10⁻⁻⁶ multiply with 25.45. Then you will get 2.187 10⁻⁴ mole per second. Right. So based on this value, so we can compare which one is the value in excess. So if you look at the value here, of course oxygen is in excess. Oxygen is in excess. Now we can calculate the remaining of oxygen when all the contaminants A consumed. Okay, then step 4, complete conversion ataupun complete removal of A. So soalan is it complete removal or complete removal? So complete removal of A. Okay, for complete removal of A, how much A required? How much oxygen required? How much oxygen required? So we need to compare it based on the stoichiometry. Okay, from stoichiometry, 1A required 2 oxygen. Therefore, how much A that we have in the reaction, thus how much A that we have here, 3.583. Thus 3.583 583 times 10 negative 6 mole per second of A required 2 times 3 3.5 3.583 10 negative 6 oxygen. Okay, so just calculate. So oxygen required equal to 7.166 10 negative 6 mole per second. Okay, and then ini oxygen required for the reaction with A. Therefore, remaining oxygen molar flow rate of oxygen at initial minus F molar flow rate of oxygen consumed. So, remaining FO2 equal to, so at initial tadi, we already calculate the value as 2.187 10 negative 4. So, minus consume 7.166 10 negative 6. And you will get the remaining oxygen as 2.115 10 negative 4 mole per second. So this is the remaining oxygen. Okay, next barulah kita calculate it in terms of concentration. Okay, in terms of concentration, because A completely removal, so remaining A equal to 0, Ca also equal to 0. But for oxygen, CO2 equal to remaining FO2 molar flow rate, okay, divide with volumetric flow rate of gas, which is 2.115 10 negative 4 mole per second, divide with volumetric flow rate of gas 25.45 centimeter cube per second. Then you will get the answer, remaining oxygen concentration.